Am happy to see so many friendly faces. Seems like the last couple of weeks I've been running all over the country, so I am glad to be here and glad that I have a talk together, and now we'll just collectively figure out what I put on these slides, and we'll see how this goes. I wanted to talk about something a little bit different. So the title that's in there, Morgan Treadwell emailed me or texted me and asked me what I wanted to talk about or what my title should be. And I didn't respond because I didn't know yet. And so I thought I would think about it. And then the next email, which was probably several weeks later, they had already made up a title. And so that's the title that's in there. And it reminds me of our friend Terry Bidwell. He used to tell me that, well, if you knew Terry, he's kind of a gruff guy. He says, well, they can invite me to talk about whatever they want me to talk about, but I'm going to talk about what I want to talk about, or whatever they want me to talk about. I'm going to talk about what I want to talk about. So that's what I'm going to do today, and it's probably going to be what I tried to do. I talk at this meeting a lot, and I wanted to put together something that was a little bit different, and I was trying to come up with this great theme. And eventually, I think the title of this ought to be Random Thoughts That Sam Thinks is Important. And in the meantime, I might not think they're that important, so we'll figure that out together. But I wanted to start. So my grandmother homesteaded not too far from here. It was actually in the northeast corner of Colorado. And my family's all from the Great Plains. And over time, I've started thinking about all the times we've snookered the people of the Great Plains. By we, I don't mean me. I mean basically everyone. And I'm kind of tired of us doing that. So I think we ought to check ourselves, make sure we're not snookering people. And so one of the things, I get a little nervous when everybody agrees at a meeting. And so I'm assuming everyone agrees that we should have fire. And I'm going to talk about how great fire is. But I'm also going to talk about some limitations to it, just because I want to sort of make sure that we don't get too far ahead of ourselves about how useful this is. Clearly, I've been talking about fire I found out today since Drac was 10 years old, and been doing research on it, and I hope to keep doing that for a while longer. But I do think it's a good thing to think about. We don't want fire to get on this list to where fire is magical. You know, we've basically told people that rain follows the plow, rain follows trees, fire's bad, then we tell them fire's good, and then we tell them cows are bad, and then we tell them cows are good, and now cows are magical in some places if you whatever you want to think about. It's sort of like we've got all of these bases covered. Even the war on invasive species, that sometimes that's good and sometimes it's not so good. So my goal is to talk about some topics in light of that. And I'm going to hit these topics pretty quickly and hopefully talk some more about them in the social time after this is over. And I'll go through each one of these, so there's no need to talk about them beforehand. One of the things I want to talk about, and Drac sort of hit on this earlier today, but is that, so it feels like we sometimes know a lot about fire, but if you compare fire to other things like grazing, we really don't know that much about fire. I mean, maybe we know enough to use it. I'm not saying that we don't, but some of the details, we don't know that much about it. And some years ago, the NRCS funded a review of all of their main practices. And I was assigned with a team to lead the fire. Does prescribed fire achieve the objectives that the NRCS had set out? Other people had other practices. The short answer from all of that was no. But it wasn't because we didn't know anything, or that fire was bad, or that grazing systems were always bad, or anything like that. The problem was the NRCS developed these objectives to use prescribed fire, and people were doing prescribed fire research as well as practices, but the two weren't really connected that well. And so a lot of times there weren't really good definitions of why we were actually burning. But in general, I wanted to go through the highlights because we reviewed all the literature on prescribed fire and rangelands, and then Ryan Lim carried it further, and we published it again in 2015, but in a peer-reviewed journal, so you can access this. But this is sort of a summary. First of all, when Drac was a 10-year-old, there was maybe 1 or 2 papers a year published on fire. Up until about 2000, and then it just really started taking off. So we're now up 30 or 40 papers that would be relevant to this meeting per year are published. So we're getting a lot of information, but you can still critique that information. So when we accumulate all of those studies, the first thing we found is that the studies are good, but they're small and short. So if you like small and short studies, that's good. But so basically, almost all the studies are less than an acre, and almost all of the studies are less than 3 years. That's not very useful from a management standpoint. So one of the things that I've tried to do is start doing bigger studies over longer time periods. I'll talk a bit about that. It's mostly talking about comparing fire to no fire, which is one of the dumbest things we can do, but it's what scientists do all the time. And we study grazing versus no grazing. That's stupid too. I mean, it's basically, instead of asking the question, how can we use fire to achieve objectives, which would mean that we do it in different ways, we're wasting a lot of time talking about no fire or no grazing. So the majority of the studies were that. It was usually just one fire. Most of the papers didn't even tell us anything about intensity or frequency or season. Some of them did, but minimal. Very limited understanding of pattern, and those of you that know me know that that's about all I ever talk about, so that bothered me, but it also gave me job security. No consideration with other things like grazing. Almost no papers existed at that time on how grazing interacted with fire. And I'm going to present some that do now. And then more importantly, what makes fire useful is how it works from a landscape context, acknowledging all the complexity, whereas the philosophy of research is often to eliminate all the complexity and control all the variability, and that has led to a lack of understanding of how fire actually works on big, complex landscapes like in Nebraska. So I would say that in the time period that I've been working, we've had an enormous growth of fire, but there's still a lot that we can learn, and I'm going to show you some examples of that. The title that someone gave me included Ceresia and Season of Fire, so I also have a bullet that says that. And I'm going to talk about that because I do think it's important. And I'm going to go back to young Drac. This was published in 2009 because he was real slow. Sorry, Drac. No, I don't remember what year we collected this data in, but this is, I really think this is important data. Lots of people talk about summer fires versus winter fires or growing season fires, and it's like there's something magical about it, one or the other. This study looked at scorch height or scorch proportion of a cedar tree, and in this case, it's along fuel load. So as you triple fuel load, you go from almost zero scorch to almost 100% scorch. That's the way it's supposed to work. Fuel load matters. This is a summer fire. So is that a summer fire? So in that case, fuel load didn't matter at all. And in reality, what mattered was whether you lit the match or not. And it killed all the trees. And the difference was that the fuel moisture was substantially different. The point I want to make here is there is no such thing as a summer fire in terms of fire intensity. You can have hot summer fires and you can have cold summer or cooler summer fires, I guess I should say. So summer fires can be useful, but it still matters how you manage those fires. And to tie in Ceresia, it was 2006 this was published. Chad Cummings, some of y'all may know Chad, works for Extension in Texas. Chad did a study where we looked at patch burning versus burning everything once every 3 years. So we burn a patch, a third of a pasture, versus we burn the whole pasture once every 3 years. So the patch gets burned in 3 years, the traditional gets burned every 3 years, but the whole pasture. The only difference was that we burned patches versus burning the whole pasture. Same amount of fire, etc. And we compared that to herbicide. Long story short, patch burning was very successful at controlling Ceresia, and I can talk about that later if somebody's interested. Herbicide did very little, and this we now have newer herbicides, and I'll talk about that in a second. So that study happened, and the data on the left side of that graph was up to 2005, was from Chad's study, and then Cooper Sherrill came back, and it was basically almost 20 years later, same pastures, we measured Ceresia cover to see if that held up for 20 years. And basically, it did. We were less than half as much Ceresia when we had patch burn as we were when we had fire and grazing, but not patch burning. And so why do I say that? I mostly want to make the point here that a lot of times we want to ask, does fire do good things for X? And the answer is almost always it depends. And lots of times it can have negative effects. And in fact, if you looked at does fire control invasive species, the answer would be no. But it can. It just depends on how you manage it. So the pattern does matter. Out of that study, half of the patches in the patch burn were done in the summer. So everyone came back and sort of said, well, the reason that you had control in the patch burn was because you burned in the summer. So in Cooper's study, we went back and looked at that, and basically we found no difference between 20 years of 7 burns once every 3 years in those pastures with no effect from summer versus dormant season fires. The biggest issue was, were the animals able to adapt and interact with burned patches as well as unburned patches? That was the difference. That didn't convince anyone, so we recently finished a study that Nick McMillan did, who just recently finished his PhD. And this is an example from the Tallgrass Prairie Preserve. Each of these pastures are over 1,000 acres. So that's our experimental unit. We have 1,000-acre pastures. The dotted lines represent the delineation of the patches. The pink is growing season, fires only. We burned a third of each pasture in the growing season and allowed the animals to do whatever they wanted to do, which what they like to do is congregate on the most recently burned area. They're in there from the time it's burned, and they're foraging on those burned areas. The green were dormant. The crosshatched was herbicide, and I'm not going to talk about that. So we've got a head-to-head comparison of summer versus dormant season fire, where we burn a patch, a third a year. First thing we found is that a major negative impact on livestock production associated with summer fires. So that still doesn't mean to me that, so it doesn't control Ceresia and it hurts livestock. Still doesn't convince me that you should never do it. In fact, I think summer fire, the biggest reason to use summer fire is you can get more fire out. But in reality, this is important. That's a pretty substantial difference from burning in the summer to burning in the, it's about 20% gain difference. And as we looked at it, we also plotted the amount of Ceresia by livestock performance, and we found that there's actually no relationship there either. So maybe it's not such a great idea to be even trying to control Ceresia, although there's some debate about whether it could get more abundant if we do nothing for a longer period of time. And then when we looked at, does Ceresia hurt biodiversity, we mostly found a positive relationship between Ceresia and other forbs. So again, it almost suggests, this is why I said in that first slide, sometimes this war on invasive plants might not be the most judicial sort of approach. Sometimes it may be. But the most important point here is that the details of how fire happens is more important than whether or not we have fire versus no fire. It's how it's done. And that's really one of the main points I want to get across today. Also, because I toured some in Nebraska earlier this summer, and I wanted to talk about this topic because one of the things we do is burn, and we often have animals that they can access forage immediately on the burn unit, and we don't defer. And so I thought addressing the question of how soon can you graze after a fire is an important question. The short answer that I'll give is before you burn, you can graze, and you can keep grazing while you're burning. And I think John took this picture, I'm not sure. The cows in Oklahoma sure seem to know what fire is, and there's a lot of examples of that. And I'll just show you some data that kind of corresponds with that. Many people who like to practice different kinds of grazing management like to argue that there's a linear relationship between the amount of forage and the quality. So it starts out, if you have very low quality, it's high, and then it linearly decreases until you have a lot of forage. That's not what we found. We found it's really high quality when there's none of it. And it goes down with just a little bit of forage. So if you're grazing with moderate amounts of forage, like we often do with grazing management, you're grazing some of the lowest quality forage that you can make available to your grazing animals. The highest quality is immediately after it's burned. And that is the best quality. And in fact, what we do, it lasts about 100 days. So we try to burn something about every 100 or 150 days to let the cattle always have something recently burned so that they can have access to this high quality forage. And I think John has successfully reduced the amount of supplemental feeding in the past, and we've done, and I'll show you a little bit about weight gain in a second. That first graph is from Oklahoma. That second graph is from Montana. So I've done it in a couple of places. I believe Catherine has done this now at the poster down here, but she's also looked at forage quality in a similar light in western Oklahoma. And so this seems to be a pretty generalized trend. If you want high quality forage, you need very low abundance of forage or amount of forage. So managing for everything in the middle, which is what we mostly do traditionally with range management, means that you're going to have low abundance and low quality, or at least not high. If an animal has a burn patch to choose from and one that's unburned, they can mix their own diet and deal with stress that way. When you look at animal performance, and I know those graphs are kind of hard to see, so you'll have to trust me. The top left shows patch burning compared to no fire. And we get about 20% more increase in livestock performance when the animals never leave the pasture and the fires happen and the animals get to forage on there. The one on the top right shows the relationship between weight gain and animal performance. And what it shows is when you burn everything, this is from the Flint Hills, and that's the way a lot of people manage, then you get a strong dependence on rainfall. When you only burn patches, you get no significant relationship with rainfall. So you get higher gain when it's low rainfall, and you get lower gain when it's high at the top rainfall. So if you were going to have a perfect year every year, burning everything would be fine. The bottom graph shows that when you create spatial heterogeneity, that's variability in space, then the variability that you have year to year goes dramatically down. The more patches on your landscape, the less year-to-year variation in production you have. So the animals seem to like, I always say we should be lucky that cows and bison aren't lighting our fires, because they'd probably light something every day. And maybe John would like that. But speaking of cows and bison, it seems like whenever you do these studies, everyone wants to compare cows to bison, which I've always thought is kind of silly, but I've done it. And but the idea is that usually whoever wants that done, they want whatever they like to be better than whatever they don't like. And there's usually a lot of other things that are different between how they're managed. But when we did manage them head to head, we found multiple sites, multiple pasture sizes, bison versus cattle, a couple of locations. We found that time since fire was the dominant predictor of where an animal would graze. If you let an animal select in this room and you have a burn patch in the corner, they should, if they read the papers, they'll be in the corner. And so that is really a strong relationship. And when we varied the size, the species, the patches, it didn't change. It was still that was the dominant predictor of where an animal would graze. And just for a final note, we also, at the time, so at the Tallgrass Prairie Preserve, they had 2,600 bison. We had GPS units on 7. They burned 50 patches. The animals had free access to the whole landscape. 34 of the patches had one of our 7 animals on it within 24 hours of the fire being lit. And that's a landscape that has a lot of fire on it. So they've got a lot of choices. They can choose things that are days old to years old in terms of amount of fire. So bison like fire. They like to graze. Cows are the same way. Okay, so a biggie. I just got back from the Ecological Society of America meeting in Montreal, and they had a fire session on can we use prescribed fire to save the world. I don't think that's what it was called, but it was something like that. And I talked there, and I thought I would sort of, we were going to have a big discussion at the end. So I thought I would sort of do a mic drop, kind of like Drac did earlier. But and so at the end of my talk, I sort of said, well, fire isn't going to get it done. let's just pack it up and we can all go home. And I put the mic down and I sat down. And then we had the discussion, and nobody would ask any questions. So I said, well, wait a minute. I threw a hand grenade in the room, and nobody's going to ask me a question about that? Shouldn't you ask a question? And most of the people in there said, oh, well, we think you're right. And so there's a lot of ecologists that were in Montreal that actually think fire isn't going to get it done. I can tell you that there are times I think the same thing. So I do think fire can be used to manage an individual property or a region really well. But when you ask the question, which isn't what John asked or Drac, but how much land is actually burned and how much needs to be burned, it's a much more difficult question. And I'm in the Prairie Project. We have Nebraska, Kansas, Oklahoma, Texas. And my simple OSU cowboy math is that we have about 200 million acres in that region that need fire. And I think it's about a 5-year fire return interval. That's 40 million acres a year. So the amount of fire we would have to have on these landscapes to save the Great Plains is a lot, on the order of 10 times more than we have now. And I would say it's even more than that, because most of what's burned now, a lot of it's the same acres real frequently over and over. And this would be a lot more fire, and there's a lot of concern that there would be, what's society going to do when we have that much fire? It is true, this is a good quote from a land fire document. 3/4 of the U.S. land dominated by native vegetation shows moderate or high departure from reference conditions, as a result of altered fire regimes. So this says a lot of land is messed up because we haven't burned it in a long time, is the summary of that. So it's true. But does that mean if we start burning it, it will immediately switch back? Not necessarily. And how much would we have to burn to actually do that? And then how does that compare to how much we have burned? And John talked about this some. And these are hard numbers to come by. I mean, they really are hard, because you can ask the prescribed burn associations, and that's good data, but there are people that aren't reporting numbers, so it's really hard to know. John already talked about this. We recently did a study, Drac with Reinhardt, who Drac mentioned earlier, where we found that the NRCS programs that we have for brush management that can be, chemical, mechanical, prescribed fire, or in this case we included wildfire, we couldn't find a signature, or a very limited signature, where we had reduced brush from these practices using actual NRI data from the NRCS. So when you actually look at it, you can't really find a signature that those programs are having much of an effect. And in fact, the one program that had the biggest effect isn't a program at all, it was wildfire. And so about the only thing that we're doing right is wildfire? Wait, that's not really something we want to say. I mean, but it is something that, in terms of controlling woody plants from a Great Plains perspective, we're not doing a great job at that right now. When you actually try to match that up from a really core, we all know, we've all been to places where we can say this place was burned and it looks good. So we know it happens, but when you try and find a regional signature, it's really difficult. And this is a different paper, again by Reinhardt, and it shows a multi-scale approach about how much fire is in the Great Plains. And ecoregion, that's the number of fires in that ecoregion from 0 to 447. And these are large fires. I think they were over 1,000 acres. You can go to county. There's some dots all the way to the right but you just can't see them. That's because they're hardly there. So basically, when you plot, and this is a 3-kilometer square that has had one fire, it'll turn up blue. A bunch of fires will turn up red. That's basically one a year. There's a few spots in there that actually have red dots. But the bottom line is there's just not a lot of fire in the Great Plains right now. I just drove from Stillwater this morning, and I didn't pass one place with dead cedar trees. And I always look for dead cedar trees. And in fact, there's MODIS. You can get remote sensing that tells you how much fire there is. And so the red sort of tells you where there's a lot of fire. And basically, we've got the Flint Hills. There are some local spots that have a little bit of fire, but when you look on the Great Plains from a regional perspective, it has a lot less fire than similar systems in other parts of the world. So we have a very prone fire system, but we're very successful at limiting the fire. So this led to some efforts that we made to try and do socio-ecological study. And that, you're probably wondering what that is. That's what we make up when we're trying to get grant money from the government. And it succeeded in this case. And so we got a grant, and we tried to do socio-ecological. And basically, the idea, seriously, is to try and link the ecology that I normally do with some social science as well, so that we can understand how people perceive the environment and why they make decisions that they make that can affect how they manage their land. And a big part of the focus is recognizing that that people that live on the land perceive that they need to do something, oftentimes through these ecosystem services, but there's also these external drivers that limit what they can do and what they can't do. But the idea is to get social scientists to work with ecologists and try to see if we can come up with some new kinds of questions to ask that will help explain why are there less people burning than we would like or than we think should be doing that. And in fact, had a former student that recently published a paper that is a socio-ecological study, and it's again these 3 regions you can see in the little maps. And we looked at tree cover and rate of encroachment, but instead of just asking ecological questions, we tried to get the best social data we could get, being non-social scientists and not really even liking people. That was kind of hard for us. But we were able to get some generalized data, and you can sort of see that, and I think this kind of stuff needs to be done, and more of it, and more complex. But things like road density positively affects the number of fires, which negatively affects the rate of encroachment. I don't know that I would have known that. So our road, that's a good thing about roads. Maybe it's a fire break thing. It makes some sense. But you can sort of start to see, and this is that these ecological variables interact with these social variables that are all very different. So the short answer to can fire save pre-Columbian grasslands? The short answer is no, but nothing can make us go back to pre-Columbian. The world has changed and it's going to be completely different. And we should stop thinking that we're going to go back to 1491 with the way we manage land. We may have to have more fire now than they had in 1491. And so there's this tendency in our profession to try and think there was something magical about the world before Europeans took over. And maybe there was, but it's gone. So it doesn't really matter anymore. So next I'd like to talk about, is fire critical for biodiversity? And the quick answer to that is sometimes. And there's a couple of examples here where shorebirds and raptors both respond positively to the fire event. So the actual fire, they respond positively. So I'll say yes, those species respond positively to fire. But most species don't respond directly. They respond to changes in the habitat. And that gets a little bit more complex. Well, beforehand, there's another example. And there's an endangered species in that picture. And it's not prickly pear. I know Morgan thought it was going to be. But there's actually a little bird. That bottom pad is a mountain plover. It's not actually a prickly pear pad. And I just use that. That's a pretty good example of something being highly adapted to fire. So, but not everything is like that. And tomorrow I have to talk about patch burning. And I'm going to talk a little bit about it here. So if we create these patches, in this case, 1 to 12 months since fire all the way to negative or to greater than 36 months, and we let animals in to decide where they want to forage, they will have a strong preference for the left. And they will avoid the right. They do not want to graze in belly-high grass. They would rather graze in putting green grass, lizard-licked, very short. On the other end, obviously the left is not going to burn again in the near future. The right is ready for the next fire. So you got mega fire, mega fuel. You can burn, you can burn under almost any condition with that much fuel. So if we take those and we spread them out, and I'm just going to do this quickly, and then we start studying stuff that I've studied in my career, and I've studied, well, you'll see a smattering. Breeding birds, where they're lined up is where they prefer. So killdeer, lark sparrow prefer the 1 to 12. Henslow sparrows prefer the greater than 36. The only way you're going to have all of these is to have every one of those conditions on your land. We also did winter birds, which is a lot harder to do, but we did them. I didn't. A student, Tori, did it. But same thing. You have to have this full array. We studied small mammals, same thing. Studied insects, same thing. Studied prairie chickens. Prairie chickens lack on one site, they nest on the other, and they've got to be in fairly close proximity in order to do that. And then we've studied a bunch of other stuff. Nutrient cycling, water, etc. And so the idea is if you want rangelands to work like rangelands, it's not whether or not you have fire, it's whether or not you have heterogeneity. And this variability is, if you burn in the Flint Hills, when everybody has a good year and you burn the whole Flint Hills in the spring, that's not creating heterogeneity, and you're not going to get this response. You have to have the patchwork in order to have the ecosystem services that are beneficial. And in fact, you can look at this. This is actually bird data. How much heterogeneity is enough? The answer is more than we made in this study because it kept going up. So we need more patchiness. And that is more important to biodiversity than fire. Somebody's going to get mad at me, and I'm going to come back and talk about that in a second, and hopefully I'll make you less mad at me. But I've been asked to talk about this in a lot of different locations. So can you make biodiversity increase with fire? And the answer is yes, you can, but does it? And I say the answer is no. Most of the time, it does not. Now, can fire be a part of the plan? Abso-damn-lutely. Excuse me. Absolutely. It can be a major part. In fact, it'd be hard to do it without fire. You can. But what's more important is, does the fire create structural heterogeneity? That's really what's driving this. So fire is the first step, but how it's done is really what's going to explain the ecosystem services that we can benefit from. Scale matters, and the point, it's less about fire versus no fire, and it's more about how can we use fire to create heterogeneity? And then just one last talk. It gets more complex. The more I study this, the more complex it gets. I should just quit, and it'd be easier. But we had a student looking at, does woody encroachment hurt birds? And in this case, we have the top set of birds all responded negatively to encroachment. The bottom set all responded positively. Now, they didn't all respond positively to cedar. In this case, there is no cedar. This is just woody cover, and these are trees above 4 meters. But the idea of just sort of saying birds benefit from fire is a little bit of an oversimplification. And in reality, what they really benefit from is heterogeneity that can be created by fire. And then just to sort of back up and bring fire back in about how important fire is, this is from a paper several years ago where I was trying to justify a focus on what should we focus on in conservation in the Great Plains. And we tried to use this argument that if you go from the left, which is an intact landscape, to the right, which is highly fragmented from cultivated and woodland, that goes up as you go left to right. Native prairie goes down as you go left to right. The potential to manage, to promote heterogeneity goes down from left to right too. So the point, you have to have heterogeneity, but you're not going to have heterogeneity if you have a cedar woodland. So just to come back around and say you still need fire or some version to make this happen. Another interesting one that lots of people like to talk about is, does fire prevent wildfire? And we were talking about it earlier, and it's messy. It's really messy. So if you have a cedar woodland, it's very resilient, and it won't burn except for under the most extreme conditions. In fact, when I was a kid, we used cedar breaks as a fire break. And so when you think of that, well then, it makes it less likely to have a fire. The problem is when the fire does get lit and it does get dry enough, you can't stop that fire. But if you turn that forest into a prairie, it probably has a higher likelihood that it's going to catch on fire. So you didn't really lower the likelihood of wildfire. You just lowered that it may not be so severe when it happens. And it turns out, this is a study where they tried to do a review, and it's quite a few years old now. But in fact, it's 20 years old. The time catches up with me. But it used to just be a recent study. Now it's like an ancient study. So I don't know how that happens. But it actually says that you can lower severity, which to me is the really issue about wildfire. Because really, it's not about the fire. It's about the fire burning your house down or causing livestock mortality or something like that. But we have studied this. And in fact, I'll just say, the top line here is fire only. The bottom line is patch burning. If you do fire only in a prairie, that dotted line there is an extreme fire that above that point you can no longer control the fire from the ground. And this is under an extreme event. Fire only limits the amount of fuel below the amount that can carry a really dangerous fire for about 6 months. Burning it and allowing the animals to congregate on it draws that out to almost 2.5, 3 years. So if you're really wanting to control fires, you need the fire-grazing interaction more than you just need fire alone. So some conclusions quickly here. Research is still limited on prescribed fire, too small, too short, limited grazing, limited application to land management. We're doing better and we're getting more all the time, and this is improving, but there's plenty for the young researchers. This is a a fertile field. There's a lot to learn. Season of fire. It can either be about the effects of fire on plant phenology, so when the plant changes what the plant's doing, and it can be more sensitive to that, or it can be that you increase the intensity by burning in a different season. It's not magical, and I think we need to try and parse that out a little better. If it's just that we're burning under more getting higher intensities, that's useful, and we might be able to burn at different times and achieve the same objective. If it's linking to plant phenology, the hard part about that is that's rarely the same time every year, and you may only have a week in which you can burn, and you may not know when that is. I guess the biggest thing about burning in the summer, I like it, and I think we should be burning year-round, essentially. How soon do you graze? Immediately. If you had to ask that question, you're too late. I would say that we can't go back to pre-Columbian grassland. And I guess the biggest fear that I have is the social science aspect of it. And when I was in Montreal, a social scientist was asked, how many fires will the public tolerate that get loose and cause things like New Mexico caused this year? And his answer was 0. That any escapes and the public freaks out. Well, I don't know if that's true or not, but I guess the point is, the thing I'm most uncertain about is how would the public respond if we increase the fire that we do by tenfold? It's a fun thing to think. We can talk over beer. Is fire critical for biodiversity? Yes and no, and it depends, and all of those answers fit in there really well. Fire prevention with fire alone is not very effective. I got a couple finishing points here. The unknown issue is carbon. And I know we've all heard of it, and we've all talked about soil health and all of these things. And there's become almost this myopic focus on carbon in a lot of cases. Carbon is not going to help prescribe fire. I mean, this is a classic study from 2000, Dave Tillman, showing suppressed fire versus moderate versus high frequency, and you can see how much carbon is in the ecosystem. These data are accurate. Now, most of that data, most of the increase in carbon is tree biomass, so it's not in the soil. But I guess the point I wanted to make here is that if we focus on one ecosystem service like carbon is trying to make us do, then fire is going to become a not very useful tool in the future. And then finally, I'll just end with this graph that Drac and I and others published this paper where we tried to argue that we've had 4 eras of socio-ecological fire. So we had the coexistence, which were indigenous people that burned a lot of stuff for a lot of reasons, including just for fun. And then we went into a suppression era where it was all the only states where you can cut a fence as long as it's to put out a fire. So it was like all hands on deck. Any suppression is what we're living in right here is a shadow era, where there's a bunch of us really intelligent people that want to use fire, but most of the Great Plains aren't in this meeting, and we need to figure out how to get them engaged as well as us engaged. And then finally, we argued the last era is one that we've just moved into, which is one where we better get used to fire because it's going to happen, and it may not be prescribed if we're not ready for it. So I'm around. I don't imagine we have time for questions or anything, but or a format for that, but I'll be around if anybody wants to talk, and thank you for letting me chat.